Okay, so what I've done here, I've got the software running, and what I'm doing is this is a, okay, let's do the hardware first. So this is a Mega 256, so it's a copy, put light on. Okay, and what we're doing is it doesn't really matter, but we're hooking some ADCs up. This is obviously plugged into the computer, and I've got some LEDs, and you can see underneath the batteries. Okay, and we're doing a test charge. The power pack isn't on at the moment. Let's just put it on, and what I've got 0 amps, which means it's currently registering. Essentially, it's being a voltmeter right now, 7.5. Okay, and so this is the ground. If you follow the wires, so I've got the black here, yeah, which is the ground, yeah, and then we've got a funny red colour, because you can see there's a difference in the colours of these. So this pinkish white is the positive, right, and that's across the 2 cells, so they're connected 1, 2, 3. Okay, this being the positive. If I move that out of the way, no, I'm not going to. Okay, but it's obviously working like that. You can see it's 7.5. These are just cross connected, and then as you can see, I've got some copper wires that are just basically acting like the BMS probing wires. Okay, so we've got one here from the ground, because I have to cross connect the grounds, and then this one is what would be the 7.5 volts, and then we've got here, this one is the halfway between the 2 cells, right? And so what I've done, you can see I've got some LEDs in here, because I don't have any, so obviously I can measure one cell directly, because this one is up to 4.2 volts, which means this is a 5 volt device, so I can measure that directly and get the voltage. But this one is up to, well, potentially 8.4, 4.2 plus 4.2. Okay, so potentially up to 8.4, which is beyond the 5 volts of the device. So I need to somehow make it so it's within the range. So what I'm doing is, what I wanted to do is, okay, so this one potentially is up to 4.2 volts. So I'm looking for a Zener diode around about 4 volts. So as to drop the potential 8.4 volts, if I subtract 4 volts from that, then that means the maximum will be 4.4 and the lowest will be 0. Okay, so which is within the 5 volt range of the device. Now I don't actually have any 4 volt Zeners. You can buy them, but I don't have them. So what I've done is I've actually used just normal diodes, and I've got a couple of LEDs there. I've got LEDs because they have a bigger voltage drop mainly, but also you can see them, so that's nice. And I thought, well, I know they're about 1.5 volts each, so 3 of them is 4.5 volts, which gives you the sort of range you want. Now, when I actually put them on, the original, in fact, I can do that. Yeah, let me do that. So, okay, so we've got 2 in now, 3.9 volts, and it's quite stable. I've also put a 1k resistor here on this side to the ground, so as to make sure there's a little bit of power drain, and it's not you know, a really small, about like a milliamp of power drain, so as to make sure to stabilize the PN junctions in the diodes. Now if I move this one out and put it onto, can I get it in? Yeah, there you go. So you can see now all 3 LEDs are now lit, right? But the voltage is now 5.7, let's say 6.9. It's quite stable because that's not moving. Okay, so we've got 5.7 volts, which is really more than I want. I really want to be I want to bring this voltage, which is 8.4 volts, to be a maximum of 5. And this is too much subtraction, because then we're going to, I mean, it'll work, because you don't really get 0 to 4.2, but it will work. But there's no need. So what I'm doing is I'm actually moving it. Sorry if it's in the way. Yeah, but I'm moving it so it's actually only 2 of the LEDs, and the third one isn't in the circuit. And now it's 3.9. You can see it's quite stable, right? So that's 3.9. Okay, so now, because I'm measuring it across the actual LED, oh dear, what's happening there? Oh, that's a bit weird. Sorry about that. Across the LEDs themselves, okay? This is going into A0, okay? And then I've got this one, which is measuring the halfway volt, the single cell voltage, right? Which then is going into A15. I just put it like that, it doesn't really matter. So, and I'm measuring the voltage actually across the, from the pack input to the point where it gets probed, right? So I'm measuring the actual difference in the voltage due to the LEDs, right? And so I put that into the software, because it's the voltage that we're reading you have to add that back on. You have to add the 3.9 back on to give you the real voltage. And so I'm putting it, and I've actually put it in braces so you can see. So the voltage that we're reading on the input, you can see it is A0. The actual voltage we're getting in is 4.2 something. But when we add the 3.9 on, we get 7.3. Okay? Now, the power pack's reading 7.5, but that's on this side. Right? If I actually move this negative, right? So that, I can put it on there, I suppose. So I can put it onto the actual negative, right? Then we're measuring from the battery to the negative. It says 4.5. So obviously it's not that, there's an inaccuracy there in that.